Let's make a diagram for this. Guys in the back. Guys, if you want to talk, then please don't sit there. Sit somewhere else. बाहर अगर आप लोग बातें करनी पहले आप आगे आगे बैठ जाओ. बिल्कुल आप उसके साथ ना बैठो. दरवाजा आ जाए. Okay, guys, we learned question 10, part C. We finished part A and B yesterday. Let's make the diagram. The mean is 24, right in the middle. It's x greater than 23. So the 23 bar is not included. It starts from 24 onwards. So yes, so it starts from 24 onwards. So this is basically x greater than or equal to 24. Strictly, if you look at it with the Poisson perspective, it is greater than or equal to 24. So starting from the 24th bar and coming towards the right, that means you will make a continuity correction, and the continuity correction should be 23.5. So this is the area that we are interested in. Everyone's okay with the continuity correction? Why it is minus 0.5? Everyone's okay with it? Okay, so what's the C value for this?
Negative 0.02.
Negative 0.021 and?
I'll round it because 0.208.
Minus 0.021. Let's check in the table. Okay. Let's check in the table for 0.021. 0.02 and then 1. Add 4 to it. 0.5084.
Yeah.
This area is 0.5084. So your final answer is 0.508. Rounded up to 3 significant figures. 0.508. Are you good? C is not correct? 0.102. Let's check it. Okay, basically you have to do 23.5 minus 24 over 24. So what's the answer? Minus 0.102. Minus 0.102. Okay, let's check. 0.102. Add 8 to it.
Oh, we have to take the root. We have to take the root.
That's the variance.
I thought we had to take the
Standard deviation, yes. 24 is the variance. 24 is the variance. Okay, 0.102.
times
0.10. Yeah, so add 8 to it, so it's 0.5406. Okay, so this is 0.5406. That means the final answer is 0.541. For the sake of the final answer, we have to give the answer to 3 significant figures. Yes. This is a slow. Okay, shall we move on? radioactive disintegration, mean count 25 per second.
Variance is also 20.
Yes. So if x follows a normal distribution, then with the mean of 25 and variance of also 25. We are interested in the probability between 23 and 27 inclusive. So 23, this is what we are searching for, right? Let's make the diagram. So mean is right in the middle, 25. Standard deviation is 5. So if 23 and 27 both are included, so the linear integration would make this into a 22.5 in this one, into 27.5. Do we all agree on this? So from 22.5 till 27.5. This is the area we are interested in.
Negative 0.5.
So C value is negative 0.5 and this one 0.5.
76 is the same.
Okay. Are we all getting this? Minus 0.5 and 0.5. Right. Let's check the table. So the probability for 0.5 is 0.6915. Right? Now, you know that the table always gives you the major area, the bigger area, the body area. So this is 0.5, no, hold on, 0.6915. 0.6915, and the area from here till the other end is also 0.6915. And remember, how do we get the in-between area when you have areas on the cross? Yes, you add both the areas and you subtract 1.
0.383.
0.38. Are we all okay till here? Any questions? Write these areas, Oh. Okay. Let me know after the class, and it's a small derivation I'll do for you. I'll show it to you. Shall we move on? Any questions? Okay, second last question. So x is a random variable here, which is number of accidents. Time interval of t weeks can be modeled by a Poisson distribution with mean 0.40. So basically lambda is 0.40. Find the probability of one of fewer accidents. So its probability of x less than equal to 1. One or fewer. In a randomly chosen 2-week interval. So yes, so 2-week interval would mean 0.4 times 2. So the lambda that you're going to take is 0.8. We know less than equal to 1 would mean probability of 0 plus probability of 1, right? Less than equal to 1, 0 and 1. We take the E out just to ease our calculation.
Zero point 8087.
0.8080. I hope everyone's getting this. So see, why didn't I use the normal approximation here? Because the lambda value is too small. If the lambda value goes above 15, then I will use the normal approximation. So see, in part B, he's saying chosen 12 or more accents in a randomly chosen year. So if he's taking a year, means how many weeks is he taking? He's taking 52 weeks. So what's the 20? Exact? Okay. 20.8. Now 20.8 is well above 15. It's even above 20. So we can comfortably use the normal approximation here. And it says it wants the probability for x to be 12 or more, which means greater than or equal to 12. So when you're using the normal approximation, you have to be very careful about the fact that is it greater than 12 or greater than or equal to 12, because the continuity correction is affected accordingly.
So we will take x into that.
You will take what will we do? So I'll say x follows a normal distribution with the same mean 20.8 and the same variance. So
Z1 is negative 2.0.
let's see. So greater than or equal to 12 would mean what would be the continuity correction? 11.5 after CC. Okay. So 11.5 is pretty much on the left. This is the area that we are interested in. Okay, so Z value
Negative 2.039.
negative 2.039. Shall we check the table? 2.039. Okay. 2.039. 2.0. Okay, this is 2.00123. This is 2.03. 2.039. The last digit. So add 4 to it.
979.
0.9792. Can you all see that? We add a 4 to it. So 0.9792. 0.9792.
0.979.
The table is already giving us the body area. So for the final answer should be 0.979. Are you okay here? At the back, any questions? Shall we move on? Done? Last question. Number of flaws in a length of clock. 0.04 mu. That's the lambda value. The mean is 0.04 mu. 0.04 mu. So what mu are we taking per day? 1000 meters. So lambda is 40. So we say we can approximate it by a normal distribution using the same mean and the same variance, right? Okay, what do we want? We want the probability of
at least 46
X.
or more.
greater than or equal to 46. Right? Okay. You have what right in the middle. Greater than or equal to 46 would become after CC 45.5. We start from 45.5. You all okay with that? So you start from 45.5 and you go ahead. So basically we are searching for the tail area this time. So whatever the table will give you, we will do 1 minus. Because the table always provides you with the body area. So what's the C value?
0.87.
0.8.
7. That's it.
70. 0.870. Let's check the table. 0.870. 0.870 is 0.8078. Can you all see that? 0.8078. So basically, yeah, this area is 0.8077. So our area will be 1 minus 0.8078. 0.19. Double 2, so 0.192. That's the answer for part A. Okay, let's see who can come with part B. Do you see that the cost is the square of the number of flaws? The number of flaws is x, the cost is x squared. How do you get the expected value of x squared? Do you know of any formula relating expected value in x squared?
Yes.
What? The variance formula, yes. Doesn't the variance formula have an x square expected value in x square in it?
Yeah.
If you remember, what's the variance formula? Okay, I'm just clearing this out. Can I clear this out? If you remember, what is the standard variance formula? Variance of a random variable is e of x squared minus e of x whole square. He's saying find the expected value of the square of x. He's saying he's asking for this. How do you find this? We have the variance with us. We already have the variance with us. What is the variance that we're using? The e of x is 40. Variance is also 40. We just used it. So variance is 40. E of x is also 40. Can you give me e of x squared? 1640. Yes. 1640 pence, or you can say 16.4 pounds. Are we good? Any questions?